Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas, and in this presentation we're going to move on to section 2 of the book, which is all about pipe length calculations. Now within this section we cover quite a bit. We're going to look at threaded pipe, copper pipe, plastic pipes, and we'll examine how do you get a measurement that you can cut for each of those types. You're going to need to know center to center, end to end. We'll talk about all of that and make sure that as you are a plumber, that you're confident and competent on how to cut and measure pipe. That's critical, right? Because in order for us to install any plumbing system, first of all, we put in the pipe and then we hook up the fixtures. So you've got to know pipe and fittings. You've got to know how to measure and cut. By the time we're done with these sections, you will. Now in Unit 7, we're going to look at standard weight pipe. And this applies to different types of pipe, including steel. But we need to look at what does that mean, standard weight pipe? To understand the answer to that question, let's have a look at this diagram that we have in Unit 7. And notice that these pipes, as you go across from left to right, each one has the same outside diameter, but the wall thickness is different, and this difference in wall thickness creates different weight of the pipe. So all of these are going to be considered a 1-inch pipe. If you look, outside diameter is 1.315. The inside diameters are going to be what is different. Now they keep the outside diameter the same so that these pipes can fit into and be connected with the same fittings. But then the wall strength and thickness of the pipe itself is different. So if we go to Schedule 40 on the left, you'll see the inside diameter is 1.049 inches. Now this is considered the standard weight. Schedule 40 is what that's called. You go on to the next one in the middle, we have Schedule 80. You notice that the wall thickness is greater. We have the inside diameter is 0.951 inches. Same outside diameter, it can be used on the same fittings, but it has a thicker wall, and again this is Schedule 80. Then you go on to Schedule 120. Now this is really thick wall, right? And we have the inside diameter has really been reduced. It's less than 3/4 of an inch at 0.599. This is still a 1-inch pipe, but we see the difference here. We have the standard at Schedule 40, the extra heavy at Schedule 80, and the double extra heavy at Schedule 120. Now you might ask, when are these different pipes going to be used? Standard pipe is what we use most of the time. Now if you get into industrial or manufacturing type situations or other special situations, you might need a thicker wall. That's where you would move to a Schedule 80 or perhaps even a Schedule 120 on these same pipe sizes. Now if you spend any time around pipe, you're likely to hear the word nominal. What does nominal mean? Well, according to the book, the term nominal size means that the size of the pipe in question is determined by the measurement across the opening of the pipe. So nominal means like you measure the opening. This would be referring to inside diameter of the pipe. And so that may vary a little bit depending on the pipe size, but in general, the larger pipe sizes, the pipe can be determined by measuring the inside diameter. Now again, that's not going to be like perfect. Let's say you have a 3/4 pipe. Does that mean it's perfectly 3/4 inside diameter? No, but it's close, and so we'll refer to it as a 3/4 inch pipe. Nominal pipe size. Now I need to pause right here and refer you to your book, and to make sure that you are aware that in the very back of your book there are a series of data tables and tables with information that are going to be really helpful to you and really important to you as you finish your exercises throughout this book. So for example, there are in the back of the book a series of tables that will help you to find the square root of a number, but I'm just going to say there, use your calculator on any square root stuff. There's a table to find the powers and roots of numbers, tables that would convert English measurement or metric measurement. Then let's move on to these data tables. Data table 1, you can see here, is decimal inch and fractional inch equivalents. This is a shortcut table for you. You can do this on a calculator and convert. So if we look at this table, there's 4 columns here. First you got your decimal inches. This is the exact decimal amount that would equate to a fraction of an inch. But then you have these others. You have on the 3rd column the low limit and the 4th column the high limit. And this gives us a range that we can round from. So for example, if I have 0.13 of an inch and I want to convert that to a fraction, I can come down, look at my limits and say, okay, well it's more than 0.09, but it's less than 0.15 because my 0.13 is in there. So that would put me within the range of 1/8 of an inch. Basically, this can help me convert my decimal inches into fractions of an inch a little bit easier. That's a good table to know about. Okay, so you're familiar with the data tables are in the back. What we're going to focus on here is data table number 2. In Unit 7, we need to look at specifically what do some of these things mean. Let's go across the top of this table. This is also spelled out for you in Unit 7. We've already talked about nominal size, so you'll see listed in that first column that we have, fractions of an inch or inches or whatever listed out. That's the nominal pipe size. If you were to measure the opening, that's going to determine the pipe you're working with, right? But then it also gives us some specifics about those pipes, including OD, which stands for outside diameter. That's in the 2nd column. Then we have ID, which is inside diameter. And so that's describing the pipe itself. The next column gives us wood auger for the pipe. Now it's talking about the drill bit size that we use in order to drill through something and be able to run the pipe through that. Now it's kind of important to note that when you drill a hole, you need a larger size than the pipe. If it fits the pipe exactly, you're going to have a really tough time pushing pipe through, because the reality is most of us are not able to align our holes exactly perfectly. So you might go through one hole and then the next one's just a tiny bit off and it doesn't go through. So we enlarge our pipe holes a little bit to give enough clearance so that the pipe can pass through. So that's what this is referring to when we say wood auger for pipe. We're going to look at the specific size that can work well for this size of pipe. Now a tap drill, to tap a pipe or something, means to drill into it and create an internal thread. This is not something that we really do anymore. They used to do this a lot in the cast iron and galvanized days. They would tap into the side of something, create some threads, and then you could thread a pipe into that. But that's what that's referring to. Okay, then we look at some columns that are specifically about the threads themselves. So we have the number per inch. This refers to the number of threads per inch that you're going to have on that pipe. Then we have the length on pipe. This refers to how much in inches of the pipe is going to be covered by threads. We also have a column giving us information on the threads on the pipe. This means how many times the threader will turn before a thread is complete. Finally, we have thread in or thread engagement, and this refers to how much of the pipe end will be inside of the fitting. All this information is used to describe the pipe and the threads so that we can accurately install them. One other important diagram that I'd like to point out here in Unit 7 is this one that shows the American Standard pipe thread. I want you to imagine what would happen if every manufacturer or tool maker had a different way of creating a thread and that would only fit with their particular fittings. That would be really complicated, because you might go out to make a repair and find, oh, I didn't have the right fitting or the right pipe or the right threads, and now I can't put this together. Fortunately, at a minimum, they've required that all pipe manufacturers create the same standardized thread so that we can work together. You know, different manufacturers may have their fittings of different shapes or sizes, but the threads should all fit the same. So here we have a diagram that's describing those threads and what they should look like on a typical pipe. You can see starting on the right side, that's the very end of the pipe, we have those threads that are cut into the pipe. Now you should have 7 perfect threads, and those threads have an angle degree of 60 degrees. This is really particular, right? But this is the standard. Now you also see from on that far right side, it says tapered 1/32 per inch. What that means is that we're actually cutting that pipe down, making it more narrow towards the end by just a fraction of an inch, so that as we thread the pipe and fittings together, they get tighter and tighter against each other. This is the taper. And it's very important that both the pipe and the fitting have a taper so that, like I say, as they thread together, they get tighter. You can see past those perfect 7 threads, then we start to come out of the pipe with those threads. There's 2 threads that are just got the tops chopped off, and then you start coming out of there and we barely scratch into the wall of the pipe by the time we come to the end of the thread. So again, this is the standardized threading that applies to all pipe, whatever brand, whatever size, to help us to make sure that these fit together properly. All right, let's have a look at sample problem number 1. And we're going to compute the maximum clearance between a 1/2 inch pipe and the wood augered hole as shown on data table number 2. So what we're going to do is we're going to say we've got a 1/2 inch pipe and we drill the hole according to the table. And then what we're trying to figure out is what is the space in between the outside of the pipe and the inside of that hole. What is that extra space that we've created? How much? And we're going to use the data table to figure that out. So let's go to step 1. It says determine the wood auger hole for a 1/2 inch pipe. So we look this up on our data table 2. We find 1/2 inch pipe and we come over until we see what the wood auger recommendation size would be, and we are given 15/16 of an inch for the wood auger. Then step 2, let's go look at the outside diameter of the pipe. We're talking that 1/2 inch pipe. As we come over and down on that table, on the outside diameter we find that it is 0.84 inches. So now we have the hole size, 15/16, and the outside diameter is 0.84. We need to convert our decimal, which is 0.84 on the outside diameter, into a fraction of an inch, so that it can be subtracted from 15/16 of an inch. We can do this, and we can do this anytime by timesing that decimal by 1. Anything times 1 is the same thing, but if we change the way that that 1 looks, we can say 16/16. 16/16 is 1 whole, but we times 0.84 by 16/16, and we're going to get 13.44/16. At this point, we're just going to round. Let's say, well, close enough. We'll just call it 13/16 is going to be the outside diameter of the pipe. So now we can take our 15/16, which was the wood auger, and we can subtract 13/16, that's the outside diameter of the pipe. That's going to leave us with 2/16 of an inch, which can be reduced to 1/8 of an inch clearance. Now that doesn't mean 1/8 all the way around, but that's the total clearance that we have between the outside wall and the wood auger. Now let me point out, there's some real importance to what we're doing there, right? When you're out in the field, you might not get down to the 1/16 of an inch trying to figure out your clearances around the pipe, but it is important that you get a hole that's close enough to the pipe that it's not huge, right? You don't go a 4-inch hole in a 2-inch pipe. You just destroyed the whole structure by doing that. So obviously we can't go too big on the hole, and at the same time, you don't want a hole that's the exact outside diameter of the pipe. So if you want to speed this up a little and you don't know what size of a hole to drill, just get the pipe that you have, check the outside diameter, get a measurement, and make sure that your hole saw, hole auger, whatever you're using, is going to be 1/8 of an inch or so larger than that. You should do all right. All right, sample problem 2 has us going back to data table 2 to look for some information. It says, how far will one turn advance a 1/4 inch pipe into the fitting? So let's say you got that 1/4 inch pipe, you turn it around once, how far is that going to move into the fitting? So we go over to data table 2, and this indicates that there are 18 threads per inch for a 1/4 inch size pipe. Each full turn would advance that 1/18 of an inch, or 0.0555 inches, which really, I mean, it's 1/18 of an inch, but it's pretty close to 1/16 of an inch. We're just going to round and say every time it goes around, it moves onto the pipe about 1/16 of an inch. With that, I'm going to turn you loose on your exercise problems. In this unit, there are 5 exercise problems. They will be asking you questions referring to data table number 2. So maybe put your finger in there, you can flip back and forth. Remember that it is important that you do all of these exercises as we go through these units. This is going to help to solidify the concepts. That's it for Unit 7. Join me next time. In Unit 8, we will look at the allowances for threaded fittings. I'll see you then.